Hello, and welcome to the Evervolt Certified Installer Training Program. The first module will focus on the residential market and present the introduction to the Evervolt system. The second will focus on designing Evervolt systems. The third is going to focus on battery safety and performance. We'll follow that with how to sell the Evervolt system. And finally, we'll conclude with installation best practices. This is a brief overview of the Evervolt Certified Installer Program. First of all, you must complete the program to be able to purchase, sell, and install Evervolt systems. By doing so, you will be offered the 10-year warranty protection from Panasonic on every Evervolt system that you install. Your company will be listed on Panasonic's Evervolt Installer Locator tool online. Additionally, the leads that we generate from our web traffic will be funneled to our certified Evervolt installers, and we will be rolling out additional program benefits throughout the rest of the year as well. Why are homeowners choosing energy storage systems today? The main driving factor is resiliency. Throughout the country and much of the globe, there are natural disasters such as hurricanes, wildfires, and others that are driving homeowners to look for certain solutions to provide backup power. Time of use. Certain utilities across the country are enforcing different rates depending on the time of the day, and typically those rates are more expensive during the evening hours. With an energy storage system, you can capture your PV energy during the day and utilize it at night when your electricity rates might be more costly from the grid. Zero export. Some utilities do not allow energy to be exported to the grid from your solar PV array. In this case, an energy storage system such as Evervolt would allow you to capture that energy and then use it later at night or during the evening when you need it. Demand charges. Certain utilities are enforcing residential demand charges. By using an energy storage system, you can help buffer that demand charge and reduce the overall cost that you as a homeowner might be charged. This shows the latest data from Wood & Mackenzie on energy storage deployment from Q3 in 2019. You can see at the bottom in the light blue is the residential market, and it has grown consistently and exponentially over the last couple of years. And you will see from this slide, also from Wood & Mackenzie, that this is the forecast for the next years up until 2024. You can see that in 2019, there was roughly 430 megawatts of energy storage deployed. And in this slide, the residential market is the dark blue color that you'll see on the bottom. And so in 2020, you can see that the market is expected to do more than double of where it was at in 2019. This slide shows the top energy storage states from Q3 of 2019. You can see that California is leading the way in the residential market with 46.4 megawatt hours deployed in the quarter, followed by Hawaii with 10.6, and then the number 3rd spot is Arizona with 2.7. One of the main drivers for energy storage in the California market is the Self-Generation Incentive Program, or SGIP. And this program has been developed to provide additional assistance and incentive for installing an energy storage system. New for 2020 is an equity resilience portion of the budget, which has over $500 million dedicated. You can see here that this new equity resilience is geared towards customers who have experienced public safety power shutoffs, critical facilities that are serving disadvantaged or low-income communities, food banks, independent living centers, small grocery stores, as well as residential customers who are depending on their water supply from an electric well pump. These new incentives for small residential begin February 18th, 2020. And for more information, you can visit the Self-Generation Incentive Program website or additionally reach out to CALSA. This is a look at the number of SGIP applications in the California market. You can see that PG&E, which is the blue color, is far exceeding the other utilities and applications. This is mainly driven by the recent epidemic of wildfires and and customers seeking resiliency in that market. So now we're going to take a step into energy storage fundamentals, just to make sure that everybody is speaking a common language. So first of all, we have kilowatts, which is power, and kilowatt hours, which is energy. So traditionally, solar PV systems are sold by kilowatt or dollar per watt, and energy storage systems, however, are generally sold by kilowatt hour, which is the amount of energy stored and the capacity or duration that a customer would have for their backup power needs. Often systems will state a total or usable energy capacity of that battery, and so the real key factor there is the usable energy, because that is what the battery can deliver. And the important thing to note is that is when it's new. Batteries do degrade, and so the usable energy will not stay the same throughout the lifetime of that battery. Continuous power and amps are also key metrics when evaluating energy storage systems. Continuous power will essentially tell a customer how many house loads they can run simultaneously, and the backup current is generally used to determine if larger loads such as small pumps, AC units, or other devices that have high inrush currents are going to be able to be handled by an EVERVOLT system. Here you will see the EVERVOLT system and the main advantages that the system has. First of all, it's extremely simple. There are only three major components. You'll see on the left side is the inverter, which hangs on the wall. The right side is the battery enclosure, which is floor and wall mounted. And then inside of the battery enclosure, you'll find anywhere between 4 or 6 batteries, depending on the system size you choose. And that's it. It's a very flexible system. We offer it both in an AC coupled or DC coupled format. You can install anywhere from 11 to 102 kilowatt hours of energy storage per system. And it's powerful. When you stack systems, you can get up to 13.2 kilowatts of continuous backup power and up to 69 amps of backup power. Why Panasonic? You can see here, this is our timeline of battery history, dating all the way back to 1918 when the company was established. We've been manufacturing batteries in-house since 1931, giving us a very long, rich history and timeline of R&D, safety, testing, performance, and data that we've collected over the years. In general, in an energy storage system, the battery is going to be the most expensive component, and also the one that is most important when it comes to reliability and safety. The most important factor when choosing an energy system is to choose a company that you trust, that has the quality and safety assurance for that homeowner, and to choose a company that will be around for the long haul. This is test data extracted from DNVGL's Battery Performance Scorecard. DNVGL is a third-party test lab located in California, and in this particular scorecard, they purchased off-the-shelf battery packs from different companies, as you can see here, and put them through a number of different tests. The main point of data to extract is that all of these different batteries do not perform equally. You can see that there are some clear leaders here, even though their specifications on paper should appear to be the same. So again, going with a company that is reliable, trustworthy, has been around, and has a track record for batteries is extremely important to make sure that it stands up to the warranty provided. Another very important aspect is safety for an energy storage system. Above and beyond the minimum requirements put out by UL, IEC, and UN certification bodies, Panasonic has an additional 15 severe internal tests above and beyond those. This would include anti-propagation measures, short circuit events, and various others to ensure that this is the highest quality and safest product that we can put out to the market. This is a look at the Evervolt AC coupled solution. You'll notice first of all that the AC coupled comes in a white inverter and white enclosure, whereas the DC coupled will come in a black inverter and black enclosure. So as we mentioned, there's the three main components. You'll see the inverter, the battery enclosure, and the battery module. Inside of that battery module, for those that are familiar with Panasonic cells, is the 18650, and you'll find 351 of those inside every battery module. The overall dimensions of the system will be approximately 46 inches depending on how far you mount that inverter from the battery enclosure, whereas the battery enclosure is 66 inches tall, and it's really nice that it's only 10 inches deep. So when you put this on a homeowner's wall, in their garage for example, it's a very slim profile and does not take up a lot of floor space. Similarly, this is the DC coupled. Again, the major difference is that it is black in color. The inverter is slightly bigger and heavier, and because it's DC coupled, it will accept the PV array as input on that inverter. These are the specs of the actual battery cabinet. So we sell the system in two versions, the standard and the plus. We always recommend that customers go with the plus. This will maximize the capability of the system and provide the most value over the system's lifetime. The reason that is because the inverter has an output capability of 5.5 kilowatts, but in order to achieve that full output from the batteries, you will need at least 6, which is the plus version. If pricing is sensitive with the homeowner, you can choose a standard system, which will have very good performance characteristics. However, you'll note that the 4.8 kilowatts will be the limiting factor from the battery during grid backup mode. You'll still get the same backup current capabilities from both systems, 23 amps, and you'll see here just an average backup capability of 6 and 9 hours. Again, that's just a very generic average. You'll want to, of course, take a look at that specific homeowners' loads and usage patterns to determine how long they will have off-grid capability. And the total weight is 326 pounds for the standard and 436 for the plus. Each battery pack itself is only 55 pounds, so it can be easily maneuvered and handled by a single person. This is a closer look at the battery pack itself, and one important thing to note is that it is the DCB 105 battery pack, which is also similarly used in the Generac system. However, it is not the exact same. In Evervolt, we use a parallel type of the DCB 105, and in the Generac system, they're using a series type. Here's a closer look at the specs of the individual battery pack. The total capacity is 3.38 kilowatt hours. The usable is 2.85. Something important and different that we do is limiting the depth of discharge on that battery pack to 84%. There's a lot of reasons we do this, but to the general homeowner, what this means is that battery is going to degrade less. The further the depth of discharge, the faster the degradation of that battery. You'll see the nominal voltage of 46.2, the max charge current 25 amps. The output voltage of that battery will vary from 42 to 52. And then you see the charge characteristics and the storage conditions. Storage conditions, it's important to note that the worst possibility to store lithium ion is in a high heat environment and not to cycle it at all. So if you're going to be storing the battery for more than 1 year, you'll want to reach out to your Panasonic representative for additional information on how to best protect that battery and ensure its quality and performance is available. This is a closer look at the DCB 105 battery module that we're using inside of Evervolt. First of all, you'll see that there is an off and on switch right here that will cut the power off and on to this battery module. You'll notice that the negative terminal is located on the left here, and the positive terminal for making the battery connections is located on the right. We have our communications ports located on the right hand side as well. And then you have your display switch here, which will show you an indicator as far as what the battery is doing at that moment in time. These are the various status displays that you can see on this side here that will tell you the state of charge of the battery as well as what the battery is currently doing. Now this is only really for commissioning the system or if you're troubleshooting, as our software and platform will do all of this automatically, and you'll be able to see this through the online portal and app. Now we're going to take a look at the Evervolt inverter. So as mentioned before, we have a continuous power of 5.5 kilowatts in off-grid mode. We can achieve 7 kilowatts of continuous power if you have the grid available. So this would be in a self-supply or time of use situation. You'll see the maximum power peaks at 7.5 and 9.6 for the off-grid and grid support mode. The continuous current during off-grid is 23 and during on-grid is 29. And these are the inverter dimensions that you'll see. Again, the AC coupled version is slightly shorter than the DC coupled, and the weight of the AC is approximately 10 pounds lighter than the DC. Shown on this slide are the detailed specs for the Evervolt AC coupled inverter. In general, you will not need these specs when designing a system, but they are here for reference should you ever need them. Similarly, the DC coupled inverter specs as well. One important note on here is that the DC coupled inverter can accept a maximum power input from the PV array of 6.5 kilowatts. To summarize, these are the main Evervolt benefits. It's extremely simple to design and install. It's compatible with existing PV systems. We have flexible storage options from as little as 11 up to 34 kilowatt hours per inverter, or if you stack systems up to 102 kilowatt hours. It's field serviceable, as you can see in the previous slides. The cover is completely removable. The batteries are completely removable. If one of the battery packs were to fail over any point in time in the system would still be up and running, and the other packs would be able to provide the energy storage needs. We have a user-friendly app to monitor home's energy flow and usage and change functionality, and a 10-year warranty protection provided by Panasonic. This is a look at the app available in both the Apple App Store and Google Play Store. You can see it's very simple and clean interface. On the far left is your home's energy usage between solar, battery, the home loads, and the grid. The next screenshot shows a detailed look at the statistics of the system as far as what is being imported and exported, again between the home, solar, grid, battery, charge, and discharge, where you can toggle the various options on and off. And there's also the day, week, and month view, and you can see that the date can be changed as well, and you can cycle back to different dates in history here. The next screenshot shows the timeline, and this is a view of the day, so you can see the hours throughout the day are shown here. And then again, you can toggle the different sources on and off, and at the bottom of the screen it will show the aggregate data between the production of PV, the grid, the battery charge and discharge, and your home consumption. The far right screenshot is the system screenshot, and this is where the homeowner can change the different modes. They can set their battery reserve to have a certain depth of discharge of that battery. They can put their system in pure backup mode if they think that a storm is coming or that there will be a power outage that is imminent. So again, very easy to use and very simple. And that concludes our Module 1, the market overview and introduction to Evervolt. We'll now move on to our second module, which is how to design an Evervolt system.